Welcome to CW 4.1. Today we're going to be reviewing limits. So the first thing to note is this expression or this equation. So write this down and you should be able to tell me what each of these things is going to mean. So for example, this bottom part is going to mean as x approaches a from both the left and right, and then this part right here is going to be f of x approaches b. So you put it together, it means the limit of your function as x approaches a from both the left and the right, f of x approaches b. So that's what this right here is saying, and that's what we talked about last class. So let's do a couple examples here. Example 8, find the limit of this function. So obviously to graph this would take a bit of time. So your first option is going to be simply plug in the value. So put a big star here. You plug in the value when you can, and that's going to be kind of the most obvious thing to do. So as x approaches 3, let's just plug in 3 right there. So 4, let's plug in 3, so 2, 3 squared minus 6 times 3 plus 5. So 4 times 27, that's 108, plus 18 minus 18 plus 5. Those cross out, we get 113. So the limit is 113. Let's do this one right below it. We can see that same idea. Let's just plug in 1. So that's going to be 1 minus 3 plus 7, all divided by 2 minus 5. That will be 5 over negative 3. So notice how for all of these, we're focusing on this part right here. And this is the value we're plugging in. So plug in this value. And for that, and that's it for those. Pretty straightforward. Now we go here. So notice how for these, it's a constant function. So it says limit as x approaches 4 of 7. Now notice how if you plug in the 4 for x, so there's nothing that can happen here, right? There is no x, which means the limit is simply 7. Now that should make sense because if you imagine the graph, the constant function is just a horizontal line. So no matter where we pick, like let's say this is y equals 7, we can pick anywhere on this graph and the limit should be that exact same value. So for b, we can see the limit should just be negative 5. So to summarize, let's write the limit as x approaches a for some constant c, that's going to be c. So for those, not too bad, pretty straightforward. Now for here, we have one-sided limits. So notice how we have this notation, this 2 minus 2 plus. So recall, the 2 minus is going to mean from the left. So for this one, if we're approaching from the left, what that means is we're going to plug in 2 to this equation right there. Because look at this, right here, this means use this if x is less than 2. So if you imagine a number line like right here, less than 2 is referring to this part, which means you can see we're approaching it from the left. That's what that would mean. So plug in 2 right here, we get 9. So for this one right here, we can see that means from the right. So we're going to have to plug it in to that part because greater than 2 is going to be on the right side of 2. So plug in 2 to the bottom one, and we get 7. So for this last one, it says 2 from both directions. Since both of these are 2 different numbers, we learned last class that would mean D and E. It does not exist. And here's our last example. Let's look here. So notice how if I plug in 3, look at what happens here. I get 9 minus 3 minus 6 all over 3 minus 3. So of course the top becomes 0, but that's not a big concern. The concern is this bottom part. That's an issue because you cannot divide by 0. So that's a big problem. So what I want you to write is this. If you ever have some box, this could be anything, so I'll put a question mark here. That can be anything. But if you have the bottom as a 0, that's a big deal. We call that indeterminate form. Erase that. Indeterminate form. What that means is if you have something over 0, we can't conclude anything. Like we don't know the answer. Could be 0, could be infinity, we have no clue. So if that happens, this is what you do. You must reduce or simplify. After you've done that, then you plug in the value. So notice our goal is still to plug it in, but we have to figure out a way to reduce it or simplify it so that we can plug it in. So make sure you put this big box. So for this particular question, let's take a look. So this didn't work. I'm going to cross that out. When you're doing this, make sure you bring the limit down because we want proper notation. I'm just going to work on it algebraically. So the top I can factor, that's x minus 3 over x plus 2 over x minus 3. And you just got to think, okay, can I simplify this? And yes, you can. The x minus 3's cancel out. And now we have the limit as x approaches 3 of x plus 2. And at this point, can we plug it in? Yes, I can plug in 3 here. So the answer is going to be 5. And that's your limit. Now it's important that you follow this notation. So lim of your expression, lim expression, and that equals 5. Again, put a big star here and you get to calculus. Notation is important. What I mean by that is you wouldn't want to simply just not have this thing. You want to carry that limit down. The limit only goes away once you evaluate. So again, this limit only drops once you actually plug it in, then you can remove it and your answer is right there. Okay, so good luck on the rest of the questions and ask me questions if you have any.